Hi guys, my name is John, this is Michael.
Hi guys.
Actually we are quite happy to see so many people here, even though Jen is talking next door. It's an honor to see you. We'll be talking about Cisco NAC and how to hack it. Basically, let me just run you through the agenda real quickly. I'll do the introduction with some marketing buzz on Cisco NAC, which is quite short. Then I'll delve into some NAC technology details and into a short analysis of Cisco NAC. And after that, I will hand over to Michael, who will be basically telling you how we approached hacking Cisco NAC, what we did, which tools we used, and so on. And then at the very end, we'll show you our live demo of how we hack a Cisco NAC secured network. That'll be the end then. I see there are still people trickling in, so let's just give them about 10 seconds to sit down before we continue. Okay. So I'll start with the part one with the introduction. So why is Cisco actually selling Cisco NAC, right? That's the question. They're selling it because basically customers are willing to pay for it. I guess that's one of the most important reasons. Then you could ask, why are customers actually willing to pay for it? Well, Cisco makes some pretty cool promises about Cisco NAC. I'll show you on the next slide. That's a screenshot from the website, right? And if you go there, and the very first sentence, it tells you NAC business benefits dramatically improve security, right? And extends existing investment and so on. So they make it pretty cool promises. And that's why basically they're selling it and people are buying it. We'll talk about the promises a bit later. Okay. The idea behind Cisco NAC, for those of you who don't know, it's basically grant access to the network to a client based on the grade of compliance to the defined security policy. We define a security policy, we measure the level of compliance to the security policy, and based on that we grant access or we don't, or put it in a quarantine section or a remediation section. It's quite important to notice that this is basically a compliance solution. And if you talk to Cisco engineers, they'll also tell you so. If you talk to Cisco marketing, they'll tell you it's a security solution. And I don't know who of you attended Dan Kaminsky's talk this morning. Who was in Dan Kaminsky's talk? Remember what he said? If you're using a product which was not designed to be a security product, don't be surprised if it doesn't measure up for security, right? So same basically applies here too. The security policy can usually be broken down to things like patch level on the operating system, antivirus signatures, the absence of unwanted programs, and if the desktop firewall is up and running and stuff like that. And we want to measure compliance against that security policy. So basically, where is the policy actually measured on any kind of access device, regardless if it's wireless, a switch, a router, some VPN connection. There is a device in Cisco NAC which basically detects a new system coming up on the network, then queries the device for some credentials, some information, relays that information to a backend server, where then these credentials are compared to security policy. The backend server derives a so-called token, which is then associated with restrictions. These restrictions are communicated back to the network access device, and then they're enforced. That's basically how it works. We'll look at this in a bit more detail. So what is Cisco NAC actually, if you're looking at a technical level? Anyone understand? What is it? Chinese, Korean? I found this picture on the Chinese Cisco website, and I really liked it because that's how we felt when we started with Cisco NAC. Right? How does it work? Okay, there is a very famous picture. You'll find it in just about any Cisco NAC slide and any Cisco NAC presentation, and it looks a bit like this. I didn't just steal it; I really redrew it with Visio because I didn't want to get into anything like stealing property of Cisco. Basically what happens, we have on the client, on the very far side, on the left client, there is a endpoint security software running, which is called a CTA. It's a Cisco Trust Agent. The Cisco Trust Agent is basically what will be in the focus of our talk today. And it relays information to the access device. Depending on the kind of access device, it relays this either over layer 2, if it's talking to a switch, or over layer 3, then using UDP as means of transport. And basically, it's all wrapped up in EAP. The access device then transmits it back via radios to a backend server, which is in Cisco solutions always a Cisco Secure Access Server, the ACS, where these credentials are then checked. And we'll look at that in detail now. There are 3 different flavors of Cisco NAC. The first one, and that's the one we'll be showing also in our demo, is a NAC Layer 3 IP. That's what it's officially called. Access restrictions are implemented as IP access lids on a physical interface of a router, for example. The access device is a Layer 3 device, like a router, a VPN device, or a firewall. And the communication between the client, the CTA, and the network access device takes place using PEEP over EAP over UDP. That's just for encapsulation. NAC Layer 2 IP is a bit different. Access restrictions are again enforced as IP access lists, but not on a physical interface of a Layer 3 device, but on a VLAN interface of a switch. That's why it's called Layer 2 IP. Communication path is basically the same, PEEP over EAP over UDP. And then there's the third one, which, if you ask me, is actually from a security point of view my favorite one, which is NAC Layer 2 802.1x. As the name says, it uses .1x port control to restrict access to the network. It's obviously .1x you usually do on switches, not on VPN devices or routers. And this is basically the only NAC flavor where there's any means of authentication of the client, and where you have the option of restricting communication in the local subnet of the client. In all the other ones, you have an IP access list. IP access list basically only restricts you from leaving your local network. It will never catch inside the network, right? And that's something different here. Okay. Of course, there's some sort of different features of what's supported and which device. I will sort of go over this a bit faster so we can have more time for the show. You can all read it up. We have also a very long paper on this. And this is just a comparison of the features. Quite interesting is the Cisco Trust Agent. That's a piece of software you need to install on your notebook or on your PC to get this thing running. And it basically has 2 tasks. Its first and main task is collect data, which is so-called poster data or credentials about the client, and forward it. That's basically the main issue, or the main task of this, right? Collect, number 1, forward it to the access device, or the ACS via the access device, number 2. And quite interesting, it has a plugin interface for third-party vendors, NAC-enabled applications. Like if you have a McAfee antivirus solution, you can plug it into the Cisco NAC solution via the plugin interface, if McAfee supports it. McAfee does, in this case. And there's a second interface, which is a scripting interface. This scripting interface basically enables you, as the administrator of a NAC network, to write simple assessment scripts yourself and relay the poster data of these self-written tests, like is there registry key XYZ, what's the value of the key, and relay that back and test against that too, right? So we have a plugin interface and we have a scripting interface. Okay, and you can see that also in the architecture. You can see at the very top layer, there's the vendor plugins from third-party vendor. Cisco provides some plugins itself. We'll have a look at the Cisco plugins later on because they're quite interesting. And custom apps is basically the scripting interface. And you see that there's basically 2 means of communication with the Trust Agent, which is first of all via the API for the plugins, Cisco plugins and vendor plugins. This interface is basically not disclosed by Cisco. It's only given if you can buy a license to use it, the API. And then the custom apps plug into the scripting interface, which is well-defined, and you can access that. And then at the bottom layer, you can see there are 2 means of communication with the network. It's one EAP over UDP, and the second one is EAP over .1x for the NAC Layer 2 .1x. Okay, so now let's talk about what information is actually relayed and how does it look like. This is the so-called posture information. They are actually collected in attribute value pairs, in AB pairs. And the attribute part is quite big. First of all, there's a vendor ID. The very first part is a vendor ID, and the vendor ID goes by the IANA SMI assignment, so it's basically the same as in SNMP, if you know SNMP, right? The OID of the SNMP trees. Then there's the second part is the application type. So there are well-defined values for applications. We'll have a look at that next slide. Credential name, and then of what format the collected information is. Is it a string? Is it an integer? Is it a date format, etc. pp. Okay, and for all plugins and scripts you want to use, you need to describe the information collected, the posture information collected, in an inf file. And Cisco provides a couple of these too. So just to give you a short, okay, we can see the very left of the slide, I guess. So basically there is an ID1, application ID1 is the so-called Cisco posture agent, which is shorthand name is PA, collects information about the agent itself. Application ID 2 is Cisco host, which collects information about the host, like running, operating system, service packs, hotfixes, and stuff like that. And you see, application ID 4 is firewall, application ID 3 is antivirus, so McAfee would have an application ID of 3 for antivirus, for example, okay? And if we look at two plugins which are provided by Cisco when you just install the system, these are the so-called posture agent plugins and the host plugin, and this is basically the sort of information you can collect and relay. Information about the agent in the posture agent and the OS type and OS version and service packs and host and hotfixes and FQDN and so on through the host plugin. This will be used in our showtime, in our lab, in our demo for hacking it. Okay, we'll be hacking Cisco NAC with sort of these credential types. That's why we're talking about them here. Now, what happens if you then relay the information to the backend server? And for each application, the server basically derives a so-called application posture token, basically a label saying, okay, according to my policy, this is healthy, or according to my policy, this should go into checkup. Right? This is a so-called application posture token. And now you have a multitude of applications like antivirus and host and firewall, and you get a multitude of application posture tokens. And from all these application posture tokens, a system posture token is derived, which is basically the application posture token which will give the least access on the network. Like if you have quarantine, checkup, and healthy, effective will be quarantine, least privilege basically, principle behind this. And this posture token then is associated with restrictions, and these restrictions are then enforced on the network access device. Okay, that's how it goes. These posture tokens, application posture tokens and system posture tokens, they are well defined. They have a well-defined meaning by Cisco, and they go from healthy to unknown through checkup, transition, quarantine, infected. I will not go through this. You can have a look at it if you want in the slides. They're up on the Black Hat side. And I told you that all the plugins are described in infile, and here's just a sample of the Trend Micro antivirus infile, and you can see everything's in plain text in there. It tells you plugin name, Trend Micro antivirus, posture plugin DLL, and it tells you application type 3, which was antivirus, and then it gives you a list of attributes it relays. Attribute number 1 is an unsigned 32 and attribute number 2, again, unsigned 32. Application posture token, system posture token, they are always there. And then from 3 on, attribute 3 and onwards, there are then the actual credentials for Trend Micro, like software version, scan engine version, etc. pp. So it's all there to read. If you install it, if you install Trend Micro, it will automatically install the posture plugin, and you can just read the information. It's there. Okay, then you define a policy on the Cisco Secure ACS server. We'll also do that in our live demonstration, so if you can't read it now, it doesn't really matter if we'll do it live anyways. You basically tell it, okay, now if Cisco hosts service pack's credential, say it's service pack 2, and if Trend Micro antivirus protection tells its status is 1, which means enabled, then it'll return a posture token of healthy. Right? That's the way you define the policies. Okay. And then if you look at the router, we'll also do that live afterwards. You can then issue some special show commands, and it'll tell you, oh, you see there's one is authenticated via EAP, and it has the system posture token of Halsey, and the other one is clientless, which means it does not run the Cisco Trust Agent. And they have then different restrictions applied to these two IP addresses on the router. Okay. Now the general communication flow is basically once the device connects to the network, the network access device will then sort of challenge it for information. And the CTA then responds with its credentials. The credentials are then sent back to the ACS. The ACS does all the compliance testing and then reports it all back. It really depends on which setup you're using on how this looks in detail. There are these 3 different NAC flavors, and they all work a bit differently in the communication flow. Quite interesting. I mean, EAP is just this huge, big sort of protocol for transporting authentication information, and there are, I don't know, like 20, 30, 40 different versions of EAP or methods for EAP, like EAP TLS, EAP MD5, EAP GSM, and so on. And they differ in really what's being used in the 3 different NAC versions. 802.1x, NAC layer 2 802.1x use EAP fast. Which is quite interesting. EAP Fast was developed by Cisco as a replacement for Leap in the wireless sector, if you remember that. There are some issues with Leap, and EAP Fast has been developed to address these issues with Leap. Okay, so that's what's being used in here. And with the other 2, with the IP-based versions, where we use EAP over UDP, basically what they do is they use PEEP version 1. As EAP method. And PEEP version 1 has a quite interesting, it's quite interesting because basically what happens is the server authenticates to the client, but the client does not authenticate to the server. That's basically the issue of PEEP version 1. Okay, and that is basically also one of the things we'll exploit later on, right, that there is no client authentication, which makes it easy to sort of spoof. Okay, here again then, detailed, I'll not go into detail here, you can have a look at it. Basically what Cisco had to do, I mean, they had to do some sort of semi-documented extensions to EAP. All the gray stuff is, well, not really RFC conform or not really published or half published, or it's expired IATF drafts. So there's really not much information how they do it. Especially the EAP over UDP and the EAP type length value coding is quite difficult to get at. Okay, and if you just think about encapsulation, I guess most of you are sort of networkers guy because we are sitting here, not at Joanna's, right? So if you look at encapsulation, I mean, we have IP and then we have UDP. In UDP, we have an EAP with PEEP data and EAP TLV. Try to look at a packet and understand what's going on in it, and it'll give you a big headache. Talk about design. I believe it could have been easier. Okay, we have the format and everything set up, so if you want, you can read up on that. With a lot of research, we actually figured out most of how the packets look like, so we can actually read them. Okay, enough of the technology. Let's get into detail with a security analysis. This will be sort of my last part, and then Michael will take over. Just for a quick summary of issues. NAC layer 3 IP and NAC layer 2 IP, client authentication, none. I mean, there may be NAC layer 3 IP, you use it over VPN, so you have a sort of VPN authentication, right? With group passwords, which are really secret, and IKE aggressive mode, so no one can actually access it, right? Anyone understands what I'm talking about? No? Okay, doesn't matter. So basically the 802.1x has authentication in it, which makes it a lot better. And then the restriction from access to local subnet, also only in the 802.1x version. So basically, what I say is, basically this is flawed by design. Because what you do is you have actually an authorization on the network, right? You're authorized to access the network to a certain degree based on your level of compliance. And you do that without any authentication. Right? You do not need to authenticate to get authorized. I mean, when you talk about security, and one of the first lessons is, okay, if you want to authorize someone, you need to know who he is. That he needs to prove his identity, not in Cisco NAC. We don't need to prove identity. We can just say, I'm healthy, here I am, let me in, and you get in. Okay. And the second one, which I think is quite funny, we'll delve into a 2,000-year-old philosophy. There was a Cretan philosopher, Epimenides, and he had made a very, very famous statement. He said, all Cretans are liars, being a Cretan himself. Right? Basically, this creates a logic bomb. What happens here? Yeah, this is a paradoxon. What happens here is we don't trust the clients. That's why we want to measure the level of compliance to the security policy, right? If we would trust them, we'd say, okay, I trust them, they're all fine. Then I would not need to measure the level of compliance. So I don't trust them firsthand. So in order to grant them access, what do? I ask them, are you healthy? And if they say, yes, I am healthy, then I let them in. Right? Does that sound stupid to you? Well, it sounds stupid to me. Right? Okay. So basically, all CTAs are Cretan liars, in my point of view. Right? Okay, so let's sort of start getting at the hack. So basically what we say is they're quite simple. We are talking about a posture spoofing attack. Posture spoofing basically says, right, tell the network I'm healthy and it'll let me in. That's what we define as posture spoofing. We spoof our posture information. Of course, we can't just say I am healthy. We have to tell, oh, I'm running Trend Micro antivirus and I have Windows XP Service Pack 2 with all the latest hotfixes enabled. That's what I have to tell. Right? Okay. We are big fans of structured approaches, and so we sat down and said, okay, so let's think this through. We said, okay, who's going to be the attacker? We said, okay, there can be an insider and an outsider. An insider is a legitimate user of a NAC-protected network, like he has the credentials on the network and so on. He simply wants to not run the update or have his lead tool like have Nmap on his notebook and still get access to the network. Right? So that's basically the insider. The outsider, of course, is an external hacker who does not have credentials on the network, quite simply, and he wants to get access to the network. And of course, also run his Nmap or whatever. And then we said, okay, so what are the attack vectors for posture spoofing? There's the big one. Code my client, code an alternative client. And basically, then with that alternative client, you can just you simply control what it tells the network. That's definitely possible. It will not work on 802.1x as EAP fast for the outsider attacker. Can't work, because with EAP fast you need some, let's call it credentials, some so-called pack file which the ACS gives you. If you don't have that, you don't get access. Currently sort of development in progress. Basically, there's another way of doing it. Replace plugins with self-written ones. Take the Cisco plugin, take the Trend Micro plugin, throw them away, put in your own, and play around with these, and then control what these plugins tell the network. And that's basically what we'll be showing. Works for insider and probably not for does not work for the outsider, but there's a lot less work than the alternative client. And then there's the last one. There's the scripting interface. Well, one could think about abusing that, of just trying to force the scripting interface to just tell the network, oh, well, I'm running Windows XP Service Pack 2. I mean, there are some limitations to that, to what you can tell through the scripting interface. But we're not yet sure how strict the CTA actually enforces this. Basically, you cannot, there's a registered range of applications, and there's a free range of applications, IDs. We're talking about application IDs, and the scripting interface goes with the free ones, and telling it things like operating an antivirus is from the registered ones, and there's an enforcement that you cannot send the credentials from registered ones through the scripting interface. But we're not sure how strict it's actually enforced. So basically, you can then put up a nice table and say, okay, here's the insider, here's the outsider. These are the three attack vectors. Which does work for whom? And that's the table. And okay, I think I'm through. Thanks for listening to that part. That was the fast run through. Now comes the how we hacked it, and then there's the showtime.
Okay. The next part will demonstrate the tools and methodology we used to do our attack on Cisco NAC. And John already told you that we are very good friends of structured approaches. So, of course, we tried a structured approach to this topic. Yeah, and I will introduce some parts of that. So, first step was define what we need to know to code our own tool, to code our own plugins. Yeah. Second step was do an attack tree. Yeah, showing up the steps that may lead us to our final goal, hack the Cisco NAC system. Step 3 was evaluate all the components of the attack tree for feasibility. We had some ideas how to approach the tasks and didn't find tools that help us. We had to code our own tools. That was not really feasible. Yeah, so we didn't follow some kinds of the tree. Yeah, but other approaches looked very interesting, and we will see them 1 or 2 slides later. Okay, after finding out which steps are really feasible for us, yeah, we worked on that and spent almost our time in following these attack vectors from the tree. At some parts we were stuck and couldn't go on, so we had to start over and try the next tree, yeah, and look how we can do with that. Yeah. So step 5 in our structured approach was, okay, we have to go back maybe to step 1 and find out other things, yeah, before we can go on or get our tools working. So it's kind of a loop in our structured approach. The things we wanted to know are quite a lot, because we wanted to know how the communication is done, how the communication flow is working, what's the packet format, because Draw already told you there's not many documentation how the packets are looking. Yeah, so to code our own complete client, we would have we need a lot of knowledge how the packets are looking. The same applies to data structures, same applies to used cryptology in the software, libraries that are used, existing interfaces like the plugin interface, program flow, and authentication mechanisms in the software. So there were a lot of topics we were dealing with. So here's the attack tree, and thanks to Bruce and his famous idea how to do attack trees, we were doing our own for our poster spoofing attack. You see on the left side, one path was code the own client. Things we had to do was analyze the traffic, analyze the crypto, analyze the authentication. One idea was, okay, when we're talking about encryption, maybe we're talking about SSL or TLS. What about forcing the whole communication into an SSL null encryption, just to see the clear packets? Yeah? Or can we use an SSL proxy to look into the packets? And, of course, maybe there are some logs in the CTA that we can use for the packets. That were some of our ideas, and some of these ideas apply, of course, to the second part on the right, abuse the existing client. Yeah. First idea was, okay, we are patching the client. So make some small changes and get it work. Yeah. Use the scripting interface, but there were a lot of limitations we had to take care about. And then on the right side, replace the plugin DLLs of the CTA, especially the CTA pp.dll and the Cisco host pp.dll, which are the main functions of the plugin interface. Patch the client was not really feasible because we had to do a lot of reverse engineering of the Linux client and of the Windows client. It was very interesting to see that the software is also available on Linux. because very often when you do reverse engineering or disassembling of code, it's much more easier to read Linux code than Windows code that's always optimized. So it's harder to read the disassembly. Yeah. So finally, we decided to follow the right path, replace the plugins, and get the information we need to know to code our own ones. The tools and techniques we used started, of course, with reverse engineering. So reading disassemblies, EDA Pro was a tool of our choice. If you do disassemblies, you need EDA Pro. I think there's not any other option. And we used a very interesting new tool that is called Hexrace. I don't know if any one of you is already knowing this kind of tool. I have a slide about it later on. It's a decompiler, yeah, and it's a very promising decompiler. And of course, we did some kind of packet sniffing. We fired up Wireshark and looked at the packets to see what's in the packets, if we can identify interesting information. We did some packet diffing, how the packets changed in the request and response communication flow. And a very helpful methodology we used was debugging, of course, and especially API monitoring. There are interesting tools that hook into the functions, and you can see which parameters are passed to the functions and identify information like patch level or the host name or the service pack. And of course, Cisco is always good in doing logging. So logging was another approach, enabling all the capabilities of the products to log, yeah, and read the log files. So there's a lot of information in the log files. And last but not least, RTFM, you all know about that, read the fucking manual. Yeah, that helped a lot. Yeah. We also know that normally you don't read the manual. I don't start reading the manual too. Yeah. But we need a lot of information, and we were dealing with a scripting interface, so we started to look into the documentation, and the documentation revealed a lot of secrets about the CTA. So it was very interesting. The big one to have for the communication flow was clear text packets. The packets or the communication is encrypted using TLS, so firing up Wireshark doesn't really help. Yeah, even the SSL proxies are dealing with a port 443, TCP. Yeah, we don't use TCP and the port number 443. We are using UDP, yeah, and we are using a high port number. So all the SSL proxies were not really helpful. So wasn't an option for us anymore. Then we saw in the manual that you can enable a detailed client log. And in that client log, there are the clear text packets. So just set the log level to the highest possible value, yeah, and read the packets in clear text in the log file. So this was quite helpful. Of course, we did that. Here is a screenshot of one of the log files. So normally it's just hex encoded, yeah, and on the lower part of the slide, okay, here's my mouse, you see a message that says, "Congratulations, your system was successfully authenticated and is compliant to the security policy. Network access was granted." Yeah, that's just the German translation of that. And so it was just hex encoded, and it was a proof for us, okay, we can see the packets in clear text, and we don't have to deal with SSL proxies, like code our own SSL proxies to look into the packets. We just have to take a look at the log file. So that was quite helpful. I don't want to tell too much about packet sniffing and diffing. Yeah, I just have a screenshot showing that there are a lot of parts in the packets that remain the same. So some small parts change in the request and response packets. Yeah, like working with like ISMP. Yeah, like a ping and echo request, echo response. Yeah, so only few parts changed. That was quite helpful too, but after taking a look at the log files, we didn't dig into that too much. Then, of course, we wanted to know which cryptology is used, which tools are used to program SSL, TLS, and taking a look at the disassembly, we recognized some part of the crypto library that I used, and it was OpenSSL in a version 0.9.7g from April 2005. Yeah, and by the way, this version is vulnerable to some kind of attacks, and this software is used for cryptology. But that was only a side effect. Yeah, we didn't try to exploit that because we wanted to code our replacement plugins. So we need more knowledge about how the CTA is working, and especially what are the core functions of the software. And we identified these two functions that were very helpful. One is called nettrans event. This function is responsible for sending the packets to the wire, and this is just a function flow graph from EDA Pro, showing us other functions and procedures that are involved into the whole process. And the second function that was very interesting for us was EAP TLV handle packet. And this function puts all the information that is gathered by the CTA together for sending it to the NAD via EAP over UDP. Yeah, so it was another interesting function because here we can see which information is collected, like service pack level, like hotfixes. So we fired up our debugger of choice, and it was not OllyDebug. I like that a lot. Yeah, I use it a lot. And it wasn't, of course, SoftEyes. It was a tool that's called AutoDebug. It's more an API monitoring tool than debugger, yeah, but it was quite helpful because we figured out how the functions look like, which parameters they take, and you can feed that information into this debugger and can visualize the functions in this debugging tool. So that's quite helpful to see what's the value of the parameters. And here is, I think this way you can see it better. This is information we found that is transmitted or to the nettrans event function, like host name of the client. Then you see the name of the software, of the CTA, Cisco Trust Agent. Here over you see the operating system that is used, Windows XP Professional. Later on there's the service pack version. And here is a list of hotfixes that are installed on the client. Yeah. So that's basically the information that is collected by the Cisco host pp.dll plugin. Yeah, telling you, is your client up to date with hotfixes and with service packs? Okay, so the information that is provided and how the information looks in memory was quite clear. So we needed the understanding of the interface of the plugins. So I did some kind of reverse engineering of the DLLs, and it was quite easy because there are only a few functions that are exported, especially process posture notification, and it's nothing else than a function to visualize the posture tokens and messages that are sent. Then process posture request. That's the interesting part because in that function all the information is collected in the DLL, like hotfixes and so on. And there's another function, posture status changed, that does just a query. Are there any changes on the client? Is there a service pack change maybe, or a hotfix update, or was antivirus software enabled, disabled? Was there any kind of change? Yes or no? This is how the functions look. Especially the function query posture status change is quite short. Yeah? And the process posture notification function isn't much bigger. Yeah? But the process posture request function is the most interesting functions. And the most important part for us was just to figure out how the function is called, just to see what parameters we have to pass to the functions to code our own ones. We were not so interested what the plugin DLLs are doing inside the functions, because that's the part we want to replace. Yeah, so we just had to follow the SDK of Cisco to code or to have the interface in the right way. After we finished all that stuff, I got a test version of the already mentioned Hexrace decompiler. Yeah, that would have been really, really helpful in doing all that stuff. Yeah, but we already finished our reverse engineering. Yeah, so for us, it didn't help anymore. Yeah, but maybe in the future it will help a lot of other guys, because it's a very interesting plugin for the EDA Pro disassembler that translates the disassembly into pseudo C code. Yeah? That's much more readable than assembler. Of course, if your name is Halvar, maybe, it's easier for you to read assembler, but for a lot of other people, it's easier to read code like C code. Yeah? And I already took a look at a lot of decompilers, yeah, but almost any of them was really crap. Yeah? Didn't help in anything. But this one is quite promising. It's the first decompiler I saw that produces more than crap. Yeah. So it's really a good reason. And I tried it with a buffer overflow demonstration program I wrote some years ago. And with that small program, it's a small TCP server. Yeah. But with that program, this decompiler already produces almost the original code. Yeah. I had to do only small changes to the C code to recompile it again. So that was a really good proof for me that this decompiler really works. Yeah. And very interesting, Ilfak built this decompiler. Yeah. And I think some of you know Ilfak. He was the initial author of EDA Pro. Yeah. The software is actually in beta state, yeah, but really impressive from my side, promising. And bad news are it will be released as a commercial add-on for EDA. So if we want to use it, you have to pay for it. Yeah. But there are a lot of more interesting features that are planned, like an API to support plugins for the decompiler plugin, like vulnerability analyzers, yeah, finding buffer overflows in software. Yeah. And there's another part that's very promising, function prototype recovery. When you're doing disassembly, it's very often the hard part to find out the function prototype. Yeah? And it's planned to do that in an automatically way. So I'm very interested to see that. For now, it isn't working, but it's planned. And, very important, in the future, maybe, we don't need a lot of assembler know-how, yeah, to reverse engineer software, yeah, because we get readable C code. If you are interested in the Hexrace decompiler, for now there is one site, www.hexblog.com, where you can find information. Yeah, and thanks to Ilfak for providing me the beta version. It was a lot of fun to deal with it. Came a little bit late for our Cisco NUC stuff, yeah, but quite promising software in doing reverse engineering, in doing research, and understand how software works. Okay, so that's quick summary. We talked about tools we used. Yeah, we saw how Cisco NUC is working, yeah, and how our approach was made to hack it. So now we can start with our demonstration, with our showtime, and show you how you can circumvent a Cisco NAC protected network.
Okay. If you fell asleep, now it's time to wake up again. Right? Okay. Just for you to understand, actually, you know, let me just, so for all of you who are currently in the state of waking up, you know, we had a very big trip. We had a very, very, very bad trip coming to the United States. Like we flew on US Air. Anyone here a US Air fan? No?
What?
Okay, you know, we had to take 2 planes and both of them were broken. And we had to change to Philadelphia. The first one, you know, we got on the plane in Frankfurt and it started taxiing onto the runway. We reached the runway. The pilot said, "Oh well, we have a problem in our hydraulic system. We need to go back to the gateway." And, you know, we taxied all the way back, and they made us wait in the plane for an hour and a half before liftoff. And then we changed planes in Philadelphia, and of course, because we were an hour and a half late, we were on a very tight schedule for changing, and we had to run through customs and immigration and stuff. And of course, you know, we had a Cisco router in our checked baggage, so you know, they pulled us out and did some additional screening. We made it, and we actually got our scheduled plane going to Las Vegas from Philadelphia. Our baggage didn't, right? Then we arrived in Las Vegas with US Air and got off the plane and went to the baggage claim, and you know, we were waiting there. Half an hour later, there was an announcement like, "Oh well, the US Air flight from Philadelphia to Las Vegas has a technical problem. We can't open the baggage compartments. We can't get the baggage out. Right? You'll have to wait." So we waited another hour or so until they finally managed to get the baggage out of the plane and put it on the baggage claim belt. And our baggage wasn't then there because they had to, yeah. And so then we arrived at the hotel. Okay, and there was another part to it. I will not go into details. It was a horror trip. And they got us our checked baggage with a Cisco router a day later here to the hotel. It actually worked. And I heard US Air is very good at delivering late baggage or delayed baggage. I heard they're better than at flying planes. Well, but what happens is that, well, the router doesn't work. Screw, huh? Not cool. Fortunately, we have Plan B and Plan C. Plan B, we have a second lab back in Germany, which we can access over the internet, and that is what we'll do now. So we have an internet base, so we don't have our router here, sitting here, because it doesn't work anymore, but we'll access it over the internet. That's more or less the setup which we
planned setup.
That was the planned setup for here. Basically, there is, I think, is there a change in IP addresses, or did you fix it, Michael?
No, there's a change because
so there's a little change in IP addresses. That's basically all, right? And we are accessing through VMware and Cisco VPN connections, but it'll work. We tested it; it works. And Plan C, we have a video recorded session of the demo. That would have been Plan C, and then just doing a live comment on that. And actually, Plan C wasn't developed until last night or this morning, 2 a.m. What a late night after, we figured, oh, well, we need something, we need a fallback. The good news for you, or for all of you out here, is that, well, we'll give the recorded session to Black Hat, and they could put it up on the site as extra material, so there'll be just a video of what we'll be showing here now, if they put it up, right? So that's the good news of staying up late at 2 a.m. Okay, now I guess all of you are awake again. You can start. It was just to give you, the chance to wake up, and we'll start with the demo now. Okay, so we need to connect through VPN to the boxes. We have an ACS server, and we have a router, and we have our CTA, the hacked box is actually running on this notebook here. There's a VMware where we put the CTA and where we are hacking it. And all the infrastructure side, that is the router who is enforcing, and the ACS are back in Germany in our lab. Okay, so that's why we need a VPN connection to get at them. Okay, so that's a Cisco Secure ACS server. I guess I just start with showing you a policy. Where's the mouse? I'm losing the mouse when I'm over the ACS. Oh, here it is. And you see it's sort of going a bit slow. That's because of the VPN connection.
But at least we are happy that Black Hat provided us some internet connection that's usable in the room.
Exactly. Okay, so anyone of you familiar with the Cisco Secure ACS server? Sort of hands up. Okay, how do you like the user interface?
Or is there anyone that likes user interface?
I think it's pretty bad. Oh wow, this is really slow. I have to be careful with the mouse. Okay, configure. Okay, I just want to show you a policy. Okay, I don't know if you can read it, but we have this very nice little tool which will help you read it. Okay, so basically what it says is Cisco host service packs, service pack 2. If it tells that, then the application poster token will be healthy, and there should be a second one with the operating system. No, it's not in here, right?
No.
No, okay.
Just
so basically that's a quite simple one. So if you tell it you're running Service Pack 2, no matter what operating system, you will be assigned a posture token of healthy. And we just want to show you that it's actually working. So maybe just go and show you're getting a healthy back.
Yeah. So that's our VMware. And the VMware has the CTA installed. Yeah. And what I have to do first is connect to the network. So first I have to start a VPN connection to get that work.
Okay, now see.
So I'm a remote user dialing into the company network and must provide, of course, valid credentials. And then the system is checked later on if it's compliant to the defined policy Service Pack 2. Before I start that, maybe, of course, we have Service Pack 2 installed. That's the Windows XP with Service Pack 2. So I start the communication with a ping request, just pinging into the internal network.
I mean, any IP will do.
Yeah.
We do just do it with,
and what you see is the result.
Okay.
Yeah. So Service Pack 2 is installed, so we'll get a notification from the ACS via the NAD saying, congratulations, your client is healthy.
Okay, so this is basically working as designed, right? We can also show you the router if you want to have a look at the router. Do we have a, do we have the router somewhere? You can just.
We have to do it in the RDP session.
Yeah, should have opened the session, but the RDP session is extremely slow. You can just. Okay, just to show you what's happening on the router, just hang on with us that we get a console. We have a serial console attached to the ACS server back in Germany, which then connects into the router, so we can, while we're here, we can actually show you the router if it works. It should.
Yeah, it should.
Basically, the PuTTY session is inactive, just restart it.
Yeah, it's just
because the VPN went down and the network went down, all the PuTTY session, of course, which was in there, also went down. And we all know good passwords, right? So if the username is password, what do you think the if the username is Cisco, what do you think the password is? Okay.
You're really great hackers.
Okay, 10 score. You just scored 10 points on the password guessing. Is that you? 67.41. Check the IP address. Because it says unknown. Can't be. I guess that's the other box.
Yeah, it's the other box.
It's the other box. There are too many boxes in the network.
So there we are.
There we are. Okay, here we are. You see, it's a healthy. This is just working as designed. Nothing hacked yet. Don't believe we hacked it. Okay? Okay. You know what I'm going to do? I'm just going to step ahead. And, you know, I want to keep Michael. I'm the administrator of this network. I want to keep the bad guy out. The bad guy is standing right behind me. Okay? What do you mean, which NAC? We are using NAC layer 3 IP of the 3 flavors, just because that's the one we can access through VPN. Okay? That's one you will always do when using VPN. Okay, so let me just go back to my Cisco Secure ACS and raise the bar. I want to keep him out. What would be a good option to keep him out? Like require something he can't provide, right? You
Good
got
idea.
it. Okay, that's it. Okay, I'll do that. And now, we all know Microsoft hasn't issued Service Pack 3 right now, right? So let me just load this here, and it says Service Pack 2. And I will change this with a whole lot of patience into Service Pack 3. Can you read it, or do you want me to put up the lens? It's fine? Okay. You could also just say you... okay, so I pressed Enter 1. Now I need to submit. Now I need to submit a second time. Oh, and now it says changes will be applied only after pressing the save configuration. Right? So,
are you really sure?
Okay, so I need to scroll down, and now I say, it's freezing. I'm sorry. This is the RDP. This is the network. This is a network-related problem. Okay, now I hit it. Okay, thank you. Okay, and just to be sure, let me get back to my router, and I'll make him forget all the past sort of authentications or past assessments, which is a clear EOU all. Basically makes him forget everything he knew about NAC and stuff like that, and if I go for a show EOU all, you'll see see there's nothing in there. So if now Michael comes and makes his ping, what do we expect him to get? Probably not healthy, something else like quarantine or checkup or infected.
So I will try that.
Let's
just ping into the network.
Alarm, infected. You see a different message, and we can also check the router again, just to make sure. Where's the? No wait, where is it, Michael? Okay. So alarm.
Yeah, that's annoying, but
okay. Yeah, and if you go for the show EOU all again, okay, it tells you, okay, it's infected. We are still working as designed, right? I requested Service Pack 3, he's got Service Pack 2 installed, infected, right? Okay, you could also say something like Windows installed infected. I mean, that would be a valid policy on the ACS, right? Okay. Again, I'm the sysadmin, he's the bad guy, now it's his part.
Yeah. We told you about the methodology we used to build our own plugins. So what I want to do now is replace the original Cisco plugins with our own ones. So I already prepared that. I have a directory called demo. There are our plugins inside. But first I will delete the original Cisco plugins and then use our own ones. Because we are very efficient in programming, we reduced the code from about 140 kilobyte to 20. Yeah. So we are really good programmers. Yeah, and copy these plugins into the plugin directory. Here they go. The xp.dat file is just a text file containing the actual list of Windows XP hotfixes, because maybe you want to demonstrate I have all patches installed, so we are able to do that too. Yeah, but at first, because we replaced the plugin DLLs, I will restart the Cisco Trust Agent to ensure that the right DLLs are loaded into memory, because otherwise we would have problems. Yeah. So I just do a restart.
If you don't have the rights to restart, I mean, you would need to reboot.
Yeah.
Right, and then it's loaded. Simply, instead of rebooting, we do the quick way around and just restarting the service. Makes it a bit faster on the show time.
Okay, so now my plugins are in place. And to make things much more easier, I made a nice graphical user interface to deal with all that information. Yeah, I have one part for the CTA itself, where you can tell you, okay, I'm running the operating system, Windows XP Professional or Windows XP Home. There are a lot of different possibilities what you can tell. Yeah, the name of the trust agent that is provided, but we want to focus on the service pack because Draw raised the bar to service pack 3, and in the tool I'm supporting up to service pack 6. Yeah. So 3 was a nice idea. Yeah. It's easy to choose. And there's an option to tell how to deal with the hotfixes. There's a predefined list in the DLL, and you can load it from the xp.dat file, yeah, where the actual hotfix list is provided. Yeah, I also have some tools to update this list, yeah, to make things much more easier. And we will use the load from file options. Now we save the settings. It's just saved to the registry, and the DLL leads all the settings from the registry. And now everything should work fine. So I can try the ping command again. Oh, you don't see a message. That's because I coded my own message box. Yeah, saying, congratulations, your client is healthy. Yeah. So now we are running Service Pack 3 under XP Professional. We are really good.
Just to prove that he's actually right of what he's talking, we could get back to the Cisco router and have a look at it and just go for the show you all again, and you see it's got a token of healthy. There it is, right? Service Pack 3. I mean, you can just choose now what you want to run. You know what? I know him. He's bad. I want to keep him out of my network, and I know he has all these lead tools and stuff running on his notebook. All these bad hacker tools like ping and stuff. And I know that good antivirus software will probably not work on his notebooks because it'll just go nuts. So screaming, "Oh, I found this and that and that." So I will actually require in my policy the usage of a antivirus software. So just change the policy again. This is again the tough part. Configure. Bear with us 5 more minutes and you'll be happy to drink a beer with you afterwards. Okay. So basically what I'll leave the Service Pack 3 rule and I'll add a new rule. If I can make the mouse move there. And basically here is a list of credentials supported by the Cisco Secure ACS. And I'm just scrolling down the list, and there is a Trend Micro and antivirus software protection enabled. I'm just looking for if it's present and if it's enabled. That is it running or is it only installed? And I'm going to require it to be 1 enabled. Now I need to be careful. Enter. Submit. Then I need to assign it a token. Right? I see now it's here, and I say if it's enabled, I just give it a Trend Micro Healthy back. This is sort of the application posture token. Or maybe Michael says I should say. This is way too. I'm trying to. Okay, here we got it. Okay. And just to show you we're not faking anything, I'm changing the default behavior from infected to quarantine. Okay? So you see something else than infected and healthy. Quarantine. Submit, and then after submit I need to hit the save. Okay, so now my policy basically says you need to be running Windows XP, Service Pack 3, and you need to have Trend Micro antivirus enabled to get healthy. If any of these tests fail, you will be quarantined. That's what the current policy says. Okay? You can just verify that quickly. I know he's not running Trend Micro. Why it's healthy?
No,
are you running it? Are you already running it?
No, I'm not running it, but I think there was a mistake in the policy.
Sure.
Because It means if one or the other rule is matching, yeah, you have to do it by.
You have to you have to change the.
Yeah.
I'm a bad administrator. Don't know my system.
Okay, ask the hacker, and he will tell you how to do that.
Exactly. Right.
Okay. Just want to delete it.
Yeah, deleting is about as difficult as adding. Sorry for that. Sorry for the slow for the network access we're having here. Would have loved to show it with our own box. Would have been quite a lot faster.
Yeah. I think it's just delete policy, right?
What?
Here, right. Delete policy, right?
Yeah. You're about to delete a policy. Are you sure? Yes. Submit. 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 Save. You can just add a local policy. Yeah. Just create a complete new one. Doesn't matter. Okay. Just make it the Trend Micro one. I think the other one's working already. New rule.
Yeah.
Oh, you need to enter a name. I think it won't accept it won't submit. It won't accept submit unless you put in a name. I mean, this interface is so bad. I've been working with Cisco Secure ACS like I don't know for 5, 6, 7 years, and it's not gotten any better. I don't know. I've had a brief look at the 4.0 version. Anyone of you using ACS 4.0? Hands up. What? Not much different, is it? No. I think they put the left side, the navigation menu, has a new layout. And there is a Cisco NAC section on the left side, so you don't need to go to database configuration and so on and so on. So basically, it saves you like one click, right? When you need to get there. Actually, you know, I mean, there's these very famous Apple Human Interface Guidelines, right, written back in the 1980s on how to design human interfaces for computer software. I think no one at Cisco has ever read it. You know, they should maybe get an iPhone and look at that and make it as easy to use as an iPhone. Yeah, Cisco iOS. Command line.
That's right. I might agree with you if the coming in structure wasn't fragmented to all L.
Okay, well, yeah. But it's Cisco iOS, the shell is quite okay. I mean, if you look at old PIX boxes, I mean, this was crap. Look at the old NetRanger IDS boxes. I mean, that was worse than crap. Right, so I think of all Cisco iOS interfaces, I think the iOS shell is the best I've ever seen. I'm not saying it's like the best on an absolute scale. Right. Remember when they bought Aeronet and they had these rebranded Aeronet wireless devices? Anyone remember that? That was bad. Right, and then the Altiga, you know, when they bought Altiga for the VPN boxes, there was another one which I really never got. Okay. You got it?
Okay, after the help of the bad guy and hacker, you see the message says you need to be quarantined because I'm not running the antivirus protection.
Yeah. Okay, so we have quarantine. You can show it on the router too while you're at it. Just do it quickly. Don't need to change. Just do a show you all in the putty section. So difficult. This is really.
Yeah, but at least it's working.
It's
working and it's live. So
yeah. It's live.
Okay,
and you see
here's the quarantine posted token.
Okay, because you don't have it enabled yet. And guess what he's going to do? He's going to use his...
Of course, I already prepared another DLL that we will copy into the plugin directory, and that's at least a more efficient version of the Trend Micro plugin because we reduced it from 180 kilobytes to 20.
Again, right. I mean, this is like writing Perl, right? I mean, there's a way of doing it quite verbose, and there's a way of doing it like very condensed. You know, it's the same here. You can either stuff all the stuff into the DLLs or just, you know, make it the core function and tell it to read stuff off the registry.
Yeah. And of course, I provided some graphical user interface for the Trend Micro plugin too. Yeah, so that are the options that can be set in the Trend Micro plugin, like application version, scan engine version, DAT version, very important for the virus definition files. and if the virus protection is enabled or disabled. So, of course, we use enabled, save the settings, and try our ping again.
Yeah, maybe we need to clear in between on the router.
I think it should already
Yeah,
be
there
done.
it's healthy.
And here we are healthy again.
That's it.